Alright, welcome back everyone. Today we're going to look at quadratics and we're going to learn how to solve them by completing the square. Now remember in the last section we solved these things by graphing and looked at the places where it crossed the x-axis, and that was our solutions. Well, this is another option for that. Now quadratics follow the function f of x equals ax squared plus bx plus c. So try and remember that. And we've looked at problems like the one that's on the screen here, x plus 2 squared equals 16, in the first chapter of this. And to get rid of that squared, if you guys remember, you would end up taking the square root of both sides until your square and your square root cancel. You're left with x plus 2 equals plus and minus 4. Okay, don't forget about the plus and minus. And then back in that last section we were subtracting the 2 from both sides, and we end up with x equals negative 2 plus and minus the 4. And then you needed to simplify this if you could, which in this case negative 2 plus 4 was 2, and negative 2 minus 4 was negative 6, and those were our two solutions. And we were able to go through and substitute them back in to check to make sure they work. Well, we're going to use this same finish of that to solve what we call using completing the square. And completing the square is a couple step process to get the solutions by themselves and to solve those out. So the steps for completing the square are as follows. First step is you get it in the form x squared plus bx. Now the way to do that is you move the c to the opposite side. Okay, so it's going to be either added or subtracted to move over, and then you're going to divide by your a value if necessary, and it will be necessary anytime that a is not 1. Now once that's set up, you can start going through the process to complete the perfect square, and the process for doing that is right here in step 2. So you start by taking 1/2 of b, so whatever b is, divided by 2, and you square that number. Now with that you're going to add to both sides, and that's a big key. You have to remember that you're adding it, and it must occur on both sides. Once you get to step 2 finished, you can move on to step 3. Step 3 asks you to solve it as a square root problem, which was exactly what we did up above just a second ago right here. We solved that problem using the square roots, and we're able to figure out what the x were. Okay, so you factor it, it will be a perfect square, and then you solve for the x. So we're going to go through examples with this. If you need to, go back up, look at those notes, the 3 steps that I gave you, and help me solve these. So let's work through them. Alright, so we're going to go through these two. On the first one, so letter A. First step is to get it in the form ax squared plus bx. So that means I've got to take my 12 and I've got to subtract the 12 to the other side. So you end up with x squared minus 6x equals 7. Now notice I left a spot here. This is where I add in my next step. So you take half of your b, my b is negative 6, half of that would be negative 3, and you square it. So negative 3 squared is positive 9, and that number will always be positive because you're squaring it, and you add that to both sides. Now once you get to this point, you got to treat this like a perfect square problem. This left-hand side is the perfect square trinomial, and we've looked at factoring those before, where it will break down as x minus, and the way that these work out, and it works every single time, is it's going to be either half of b or the square root of c, and in that case it's going to be 3. And that binomial is squared, and then 7 plus 9 is 16, and you got that. And now it looks just like the problem we had up above, so we take the square root of both sides. That gives you x minus 3 equals plus and minus 4. Add 3 in both cases, and you get x equals, and then you go 4 plus 3. 4 plus 3 is 7, and then you go negative 4 plus 3, which is negative 1, and those are your two solutions. And you could prove that they work by taking them back up and substituting into those two to get your proof. So that's your steps for completing the square. Alright, let's complete it one more time using example B. So we start by subtracting 3 from both sides. That gives you x squared minus 12x equals 5. Now in this case, I take b, which is the negative 12, half of that is 6, and you square that to give you 36. Okay, so again, half of 12 would be 6. You take that, square it, you get that 36 that I've added to both sides. Now from here, we factor our perfect square trinomial. And like I said just a minute ago, it's half of b or the square root of c, which in either case is 6. And then on the right hand side, 5 plus 36 is 41, and you end up with that. Now to finish this, we take our square roots. So the square root there, the square root there on both sides. Our square and our square root cancel. We're left with an x minus 6. On the right hand side, the square root of 41 is not something that's able to be broken down, so I'm going to leave it as the square root of 41. And then finally, I add my 6 to both sides, and so you've got 6 plus and minus the square root of 41, and there's your final answer. Now depending on if you're testing on a standardized test, you may be asked to actually plug that through a calculator to find a decimal solution. In this case, if you leave it as a square root, I think that's a little bit easier to understand and work with, so that's acceptable here. So hopefully that made some sense. Alright, let's look at these next examples. Now on these next two, you have a couple extra steps. Okay, so for c, we want to get it in the right form. So the right form means that we move our c to the opposite side. So I've got negative 2x squared plus 8x, and I move my 18 to the other side by adding 18. Now if you remember back up above, it said that your a value, which in this case is negative 2, has to be 1. So we divide everything by that a value, and it must be everything. So when you simplify this down, the 2's cancel out. You've got an x squared. 8 divided by negative 2 is a negative 4x. 18 divided by negative 2 is a negative 9. Okay, now we go through our process. So you take half of b, which is negative 2. Negative 2 squared is plus 4, and plus 4. Okay, this is now a perfect square. So I go x minus, and remember it's half of b. Over on the right hand side, I've got negative 5. Now we go through, we take the square root of both sides, and you've got x minus 2 equals plus and minus square root of negative 5. Now you guys may have been introduced to imaginary numbers, but if you were to try and take this in your calculator, you would get an error. Reason is you're not allowed to have negative numbers underneath your radical, so in this case there is no real solution. And if you think about what that means, back in the last section we looked at the graphs. The graphs were the place where it crossed our axis. If there's no solution, remember that your graph does not cross your axis, and so that's what that means about this. If you were to graph your original equation, this one up here, it would not cross your y-axis. Okay, so if you get to that point and you see a negative under your radical, as far as we've come in this class, you don't know how to work with those, so you would be finished. Now for D, follows the same type of steps. I want to move my c to the other side first, so I got 3x squared minus 9x. Remember, I'm adding 3, so that gives me 24. Then you're going to divide by your a value, which in this case was 3. So dividing by a gets you x squared minus 3x equals 8. Now once you get to this point, the process is the same as we've done above. In this one it's going to be a little bit different. So you take 1/2 of b. Well, b in this case is a negative 3. So 1/2 of negative 3 would be 3/2. And then you have to square that. Well, to square a fraction, you square the numerator and square the denominator. So 3 squared is 9, 2 squared is 4. So we're actually adding 9/4 to both sides. So at this point we factor or break this down. So it becomes x minus half of b, which is 3/2. Remember, that comes from right up here, 1/2 of b. And then on this part where we have 8 plus 9/4, we want a common denominator. So in this case it's 1. We're going to multiply by 4 over 4, and that turns into, I'm going to scoot it off to the other side, 32 fourths. So adding these two together, 9 plus 32 fourths, gives you 41 fourths. Alright, once you get here, you take your square root. So square and square root cancel. You've got x minus 3 halves. On the right hand side, remember your plus and minus. The square root of 41 is the square root of 41. Now the denominator, if you take the square root of 4, you get 2. And that is doable. Okay, so you want to solve it out as far as you can. And then finally, we're going to get x by itself, so add 3 halves, and we end up with 3 halves plus and minus the square root of 41 over 2, and there are your values for x. Okay, so that is the process for completing the squares. It's a 3-step process. It takes some practice and getting used to, but if you work through them and follow those steps, I think you guys will catch on. So I would like you to pause the video, take a couple minutes to work through these, and I'll be back in just a second. So pause the video, give these a try. Okay, so hopefully you guys had plenty of time to work through these. Let's see how you guys did. So, you move your c to the other side first. You get 1/2, or x squared minus 2x equals 14. So add 14 to both sides. Take half of b. Half of this 2 is 1. 1 squared is 1. So I'm adding 1 to both sides. Okay, then I factor. So I've got x minus, whoops, sorry about that. This is 1/2 of b, so it's x minus 1 squared equals 15. Now once you get to this point, you take that square root. So your square and your square root cancel. You got x minus 1 equals the plus and minus square root of 15. That cannot be reduced. And then add 1 to both sides. So you get 1 plus or minus the square root of 15. And hopefully that's the answer you guys were able to get. Now for the final one here, you have f. So f, first step, you have to divide by 4. And that leaves you with x squared plus 6/4, which reduces down to 3 halves. And then over here you've got 12 divided by 4, which is 3. Okay, 1/2 of b. Well, b is 3 halves. When you take 1/2, you multiply by 1/2. So that gives you 3/4. Squaring that gives you 9/16. And that's what gets added onto both sides. And I understand fractions. I know how they work. And it causes a lot of people grief. Just stick with it. Okay? You'll be able to work through these. Just stick with them. Alright, so factoring this now. You've got x plus half of b, which is 3/4. Okay? On the right hand side, that's 3 over 1. We need that common denominator to be 16. So we're going to multiply both of those, numerator and denominator, by 16. So 3 times 16 is 48. So combining those two together, that's going to give you 57 over 16. Now last couple steps, we take that square root, those cancel. So I've got x plus 3/4 equals the plus and minus square root of 57 over 4, because the square root of 16 is 4. And then finally subtract the 3/4. So you've got negative 3/4 plus or minus the square root of 57 over 4. And there's your final answer. Alright, I know these are a challenge. Keep working through them. These numbers are important. Okay, we want to know where these graphs cross these x-axis, and that gives us our solution for those. Alright, final one. We got a word problem. When are we ever going to use this? Well, a lot of businesses can make projections based on these types of models. So if you're buying new jerseys for a sports team that followed this model. So this is the equation for this set of jerseys, where C is the cost to buy them X jerseys. Okay, so C and X tells you what they're for. How many could you buy with $430? Well, what we've got here is we've got a cost. We've got $430. So if we take that cost, substitute it into the equation, we've got 430 equals 0.1 x squared plus 2.4x plus 25. And we want to find x. X is how many jerseys we can buy. Well, go through your steps. So we subtract 25 from both sides. So you end up with 405 equals 0.1x squared plus 2.4x. Okay, now we're not allowed to have that 0.1 there, so we're going to divide everything by 0.1. Now 0.1 is 1/10, and we could then multiply by 10 and get these same values. Okay, so dividing by 0.1 or multiplying by 10 is the same thing, and that ends up getting you 4050 is equal to x squared plus 24x. Now follow the steps that I've told you before. So on this right hand side we take half of b. Half of b would be 12. 12 squared is 144. Okay, so we add 144 to both sides. So on that left hand side I've got 4,194 is equal to, and remember we break this down, x plus 12 squared. Now we square root both of these. Okay, so at this point, because we're dealing with an actual real life type of situation, I want to know what the square root of 4,194 is. And it works out to be 64.76. So I got 64.76. And that equals x plus 12 after those cancel. Then you finalize this by subtracting 12, and we end up with, over here on the left, x equals 52.76 jerseys. Well, we know we don't really want that 0.76 jerseys, so we could buy, with that amount of money, 52 jerseys, and there you go. Okay, I want you guys to pause the video, give this a quick try, try and figure out how many jerseys you could get with $620. I'll follow the same process. I'll be back in just a second. Okay, so you guys hopefully had some time to do that with the pause. Let's see what you ended up with. So you substitute in your 620. So you got 620 equals 0.1x squared plus 2.4x plus 25. So start by subtracting 25. That will give you 595 equals 0.1x squared plus 2.4x. Then you divide by 0.1 or multiply by 10. So that gives you 5,950 equals x squared plus 24x. Okay, take half of b, which is 12, square that, that gives you 144. So this should look familiar to what we did just a couple minutes ago. On this side, you got 5,950 plus 144, which is 6,094. Over here, you've got x plus 12 squared. Square root both sides. So we're going to take the square root of 6,094, which is 78.06. And if you remember, we dropped that off in the last example, so I'm just going to leave it off now because we don't want that part of a jersey. And then you subtract 12, and you end up with x equals 66 jerseys, and there you go. Okay, so that's completing the square. This is one method that we can use to solve these equations. Hopefully that made some sense. If you need some help, contact me online. Otherwise, good luck with your assignment, and we'll talk to you soon.